Alex, thanks for joining us. Listeners everywhere have been buzzing with this question. How do batteries really work? I mean, we use them every day, but the science is still kind of a mystery for most people.
Waylon, it's great to be here. You're right. Batteries are everywhere: phones, cars, even your kid's toy robot. But the actual process behind how they power these gadgets is a wild story, starting with, believe it or not, frog legs.
Frog legs powering batteries? That sounds like something out of a mad scientist's cookbook. But before we jump into the frog pond, what's your best guess about how batteries push electricity around?
If I had to explain it simply, I'd say a battery is like a tiny warehouse for energy, storing it up and then carefully releasing it when you need it. But the way it was discovered is anything but simple. There's a real twist coming up.
All right, you've piqued my interest. Let's rewind a few centuries. Who was this frog leg-obsessed scientist, and what exactly happened in his lab one fateful night?
That would be Luigi Galvani, an Italian scientist from the 1700s. He was dissecting frog legs soaked in salt water, trying to unlock the secrets of how muscles work. Out of nowhere, the dead frog's leg twitched when he cut it. Imagine the horror and excitement.
So a dead frog suddenly kicking on the operating table? I'd probably scream and run for the hills. Did Galvani think he'd stumbled onto some weird magical property in frog muscles?
Absolutely. Galvani became convinced that muscles contained some kind of animal electricity. He thought he was on the verge of discovering the secret to life itself. Little did he know, the real secret was hiding in plain sight right in his tools.
So Galvani's frog legs are twitching, but here comes Alessandro Volta, ready to rain on his parade. What did Volta see that Galvani missed?
Volta noticed something weird. The frog's leg only twitched when two different metals touched it: copper and iron. He suspected the magic wasn't in the frog, but in the combination of metals and salt water. Galvani was basically making a science sandwich without realizing it.
A science sandwich now. I'm hungry and intrigued. So Volta sets out to test his theory, right? Did he ditch the frogs altogether?
Exactly. Volta replaced the frog legs with metal discs and soaked cardboard. By stacking these metal and salt combos, he created a steady electrical current, the first true battery. It was a real aha moment that changed science forever.
Let's get hands-on for a second. Volta's invention, the so-called voltaic pile, sounds like a stack of high school cafeteria trays. How does it actually generate electricity?
Great visualization. Picture a club sandwich, alternating layers of copper and zinc, separated by saltwater-soaked cardboard. Each metal pair acts like a tiny pump, pushing electrons from one side to the other. Stack enough, and you get a noticeable jolt, literally a pile of power.
And this was before anyone had seen a light bulb or heard of smartphones. What did people even do with this new source of electricity at the time?
Honestly, at first, not much. It was a scientific marvel, but practical uses came later. People sparked small fires, did parlor tricks, and, of course, shocked each other at parties. Imagine the original electric handshake.
It's wild that something invented for party tricks now powers our daily lives. When did batteries make the leap from science experiments to essential tech?
The real turning point came in the 1800s with telegraphs and early lighting. As technology advanced, batteries became more compact and reliable. We went from Volta's piles to the modern AA, and eventually into the lithium-ion era, which powers everything from watches to Teslas.
So next time I'm cursing my dead phone, I should thank Volta and maybe a frog or two. How have modern batteries improved on his original design?
Modern batteries use advanced materials and chemistry for efficiency. Instead of salt water, we use special electrolytes and separators. The metal pairs have changed, but the basic ideat different materials and a conductive solution remains just as Volta discovered.
Let's dig deeper. What's happening inside a battery, chemically speaking, that makes your flashlight shine or your electric car zoom down the road?
Inside, you have a chemical reaction called a redox reaction. One metal loses electrons, the other gains them. Electrons travel through an external circuit, say, your flashlight's wiring providing power. Meanwhile, ions move through the electrolyte to balance the charge. It's like a relay race for subatomic particles.
That's a great analogy. So, every time I flick on my flashlight, I'm setting off a microscopic marathon inside those AA batteries?
Exactly. Billions of electrons sprint from one terminal to the other. When the chemicals run out of juice, the race is over, your battery is dead, and it's time for a replacement.
Not all batteries are created equal, right? Why do we have so many types alkaline, lead acid, lithium-ion, and what's the deal with those button cells in watches?
Different batteries suit different needs. Alkaline cells are cheap and good for toys, while lithium-ion packs a punch for laptops and cars. Button cells are super compact for gadgets like hearing aids. Fun fact, the world's largest battery is the Hornsdale Power Reserve in Australia, and it can power 30 homes for an hour.
30,000 homes? That's impressive. So, is there a perfect battery, or is it all about trade-offs?
Total trade-offs. Some batteries last longer, others are safer or cheaper. Researchers are always looking for that holy grail, something cheap, powerful, safe, and eco-friendly. We're not quite there yet, but the hunt is on.
Let's bust some myths. I've heard everything from recharging batteries in the freezer to draining your phone before charging is best. Any truth to these?
Most are urban legends. Freezing can damage batteries, and modern lithium-ion batteries actually prefer partial charges. Draining them completely shortens their lifespan. It's like the difference between sprinting and marathon. Running steady wins the race for battery health.
So, next time someone tells me to stick my batteries in the fridge, I can safely ignore them?
Absolutely! Just store them in a cool, dry place. And remember, battery tech is always evolving. What was true for your granddad's flashlight doesn't always apply to your smartphone.
Speaking of evolution, electric cars are everywhere now. How have batteries shaped the push toward cleaner, greener transportation?
Batteries are the heart of the electric car revolution. Lithium-ion cells offer high energy density, letting vehicles travel hundreds of miles on a single charge. In 2023, EV sales jumped 55% worldwide, showing just how much batteries are driving sustainability efforts.
It sounds like batteries are key to fighting climate change, but are there downsides we should know about?
Great point. Mining for battery materials can harm the environment, and recycling is still a challenge. But researchers are exploring alternatives, like sodium-ion and solid-state batteries, which could make the future both electric and eco-friendly.
Let's peer into the crystal ball. What's next for batteries? Will we see game changers like wireless charging everywhere, or batteries that last a decade?
We're on the cusp of major breakthroughs. Solid-state batteries could double capacity and charge in minutes. Imagine charging your phone in 10 seconds or having electric planes. The possibilities are electrifying, pun intended.
Sign me up for a 10-second phone charge. Any advice for listeners who want to stay curious about science and technology?
Absolutely. Always ask questions sometimes. The weirdest stories, like twitching frog legs, lead to the biggest discoveries. Stay curious, and who knows? Maybe you'll invent the next big thing in battery tech.